3D printing is transforming rocket manufacturing as it allows you to create more complex components such as engines, turbopumps, and tanks. There are several advantages to 3D printing, the main one being rapid production, cutting down costs, being able to use complex geometry, using specialized materials, and being able to reduce parts. This video explores the process of 3D printing, the different types of 3D printing, what rocket parts are 3D printed, and different examples of 3D printing in rockets. "3D printing is a type of additive manufacturing, which basically means layers are added on top of each other using digital computer-aided design data to create an object. First, an object is designed on a computer-aided design software such as Autodesk or Tinkercad. The file needs to allow 3D printers to read it to manufacture the object. The software slices the design into layers for the 3D printer to then deposit the material in those layers in order to create the object. Some 3D printers melt and extrude filament, while others use a light source to cure liquid resin into hardened plastic, or fuse small particles of polymer powder at high temperatures to build parts. Printed parts may need to be rinsed in isopropyl alcohol in order to remove uncured resin, use post-curing to stabilize mechanical properties, cleaned with compressed air or media blaster to remove excess powder, or have support structures that need to be removed. There are also many post-processing methods for this, such as vibratory tumbling, vapor smoothing, dyeing, painting, as well as many different coatings such as metal, ceramic, powder, or polymer coatings. After this, your designed product is ready to be sold. Every space company has their own approach towards 3D printing, but there are 7 types of additive manufacturing: material extrusion, binder jetting, direct energy deposition, material jetting, powder bed fusion, sheet lamination, and vat polymerization. Of these, powder bed fusion, or specifically selective laser sintering, and directed energy deposition are the most common. Selective laser sintering is a method of powder bed fusion. In this process, lasers melt and fuse a metal powder that is distributed layer by layer to create an object. A roller in the 3D printer passes side to side, spreading a thin layer of powdered material onto a build tray where the object is being created. The laser then draws the design from the CAD software by applying heat that binds the materials together. The tray lowers one level and the material is built on top. This continues until the design is complete. This method is the most common, as it produces high-strength, complex, and lightweight components without needing support structures. This method is rapid and cost-effective, and it allows the components to be made out of heat-resistant metal alloys needed for aerospace. Some parts that are a lot bigger use the directed energy deposition method instead. Powder bed fusion needs to be encased in a powder bed chamber, while directed energy deposition does not. This allows this technique to build larger objects. A multi-axis robotic arm has a nozzle which has a material, usually a metal alloy, being fed through it. An energy source, usually a laser, electron beam, or plasma arc, instantly heats the metal to deposit it onto the build tray. This constructs an object. 3D printed rockets focus on propulsion and structure to reduce weight and complexity. Key components that are 3D printed include engines, turbopumps, combustion chambers, injectors, fuel valves, nozzle belts, propellant tanks, and fuselage structures. These components do not need a high level of complexity and strength, making them a good choice to be 3D printed. Other parts have specific chemical, thermal, or strength thresholds, or have specific material strengths or sizes. Traditional manufacturing is often faster, cheaper, and more reliable for larger, simpler objects. Because of this, there has never been a rocket that is completely 3D printed. However, there are several examples of 3D printing in rockets, and we will explore 5 of these examples now. Terran 1 was a rocket built by the launch startup Relativity Space that aimed to take a 3D printing approach towards rocket manufacturing. The rocket was built in March 2023 and was the first rocket built almost entirely from 3D printing. 85% of its mass was 3D printed, which includes the propellant tanks, which stores the fuels and oxidizers, as well as the fuselage, which is the main body structure of the rocket. The 9 engines that powered the rocket were also 3D printed. The rocket was 3D printed using the directed energy deposition method, which was mentioned before. To ensure that the rocket could be launched, the rocket passed the max Q, which is the maximum dynamic pressure, and main engine cutoff. This meant the rocket could withstand the extreme forces of launch. Rocket Lab created a rocket called Electron, which is a commercial launcher and has completed over 40 successful missions. Its engine, named the Rutherford engine, has 3D printed combustion chambers, injectors, pumps, and main propellant valves. It used electron beam melting, a type of powder bed fusion manufacturing method. SpaceX has used 3D printing since 2014, where the main oxidizer valve of the Falcon 9 was the first 3D printed part to be launched for the TICOM 6 mission. The part was for the Merlin 1D engine on the rocket and was produced using Inconel, which is a high-performance superalloy. This is a metallic material designed to withstand high mechanical strength, resistance, and serviceability. The valve was printed in only 2 days instead of months like usual, and it had a lot more strength and ductility compared to traditional castings. The Super Draco thrusters are used for the Dragon spacecraft's launch escape system, which is a critical safety mechanism used to rapidly separate a crew capsule from a failing rocket. The combustion engines in the Super Draco thrusters were 3D printed using powder bed fusion. It was the first fully printed rocket engine to be qualified for flight and can be restarted multiple times. The Indian startup Agnikul Cosmos launched their rocket Agniban Sorted, which stands for Suborbital Technological Demonstrator, in May 2024. A rocket used a 3D printed single-piece semi-cryogenic engine, meaning it was a liquid rocket engine using liquid oxygen as an oxidizer and refined kerosene as fuel. It was the world's first rocket using a single-piece 3D printed engine, showing how its manufacturing was highly efficient. Thank you for watching today's video. Next video, we will be exploring how reusable rocket legs function. Don't forget to like, subscribe, and hit the notification bell to never miss a video. Bye!